Sulfides are the sulfur analog of ethers, just like thiols are the sulfur analogs of alcohols. So the sulfides will have similar properties as ethers. Let's first take a look at the preparation of sulfides. If we want to prepare symmetrical sulfides when the two R groups are the same, we can react two equivalent of an alkyl halide with sodium sulfide. And with two SN2 reactions, we can make the dialkyl sulfides. For example, here we have an alkyl dihalide. You can treat it as two alkyl halides, right? So the sulfur, the S2 minus, will attack on the carbon with one chlorine. So the sulfur replaces one chlorine. And then the same sulfur can serve as a nucleophile one more time to attack on the other carbon with chlorine. And this will be an intramolecular SN2. And as a result, we will have a cyclic sulfide. So if we start with an alkyl dihalide, it's possible that a ring will form with sulfur in it. Regarding unsymmetrical sulfides, we will use the same method for ether preparation, which is the Williamson ether synthesis, right? To make ether, we want alkoxide and alkyl halide. To make sulfides, we will need the Rs minus, the alkyl sulfide reacting with an alkyl halide. And again, this will be an SN2 reaction. So here's an example. If we start with a thiol and an alkyl halide, and we treat them with a base, the base will deprotonate on the thiol to give the S minus, which will be the nucleophile to serve to attack on the alkyl halide, give the final product. So here is the intermediate, and an SN2 reaction, a sulfide is formed. Lastly, I want to briefly mention the oxidation reaction. When we talk about the thiol, we've also mentioned this, that when the sulfur-containing compounds are oxidized, it is the sulfur atom that is oxidized, not the carbon. So when the alkyl sulfide is oxidized, the sulfur atom is oxidized here. It first forms sulfoxide, and the sulfoxide can be further oxidized to form sulfone. And we've also mentioned the disulfide bond before, right? So when two thiols react with each other to form disulfide bond, that's also an oxidation reaction. And when the disulfide bond breaks to give two thiols back, that will be a reduction reaction.